these three triangles do not have the right angle symbol there. So there they are. Now they are right triangles. These are 30, 60, 90 triangles. Let me go ahead and put these 30, 60, 90 in there, the 30 and the 60 anyways. Put the 90 already. So there we go. Now we're ready to work. So let's start this one here, the example on the left. Let's start with the short leg. Okay, let's start with the short leg. Let's say this short leg is 5. According to our conjecture, the way to find this high length of the hypotenuse, which is identifiable by, because it's opposite of that right angle, is just 2 times the short leg, or we can say is 10 units, whatever those units happen to be. If we're trying to find the length of the longer leg, which is opposite of that 60-degree angle, it's the short leg times radical 3. That's what it's saying. So if this was a question in one of our homework, we'd be done. But let's go ahead and see if this actually works. Does a squared plus b squared in fact equal c squared? Let's see. So again, a and b really don't matter, so let's just go ahead and throw them in there. Let's do a little bit of substitution. So we have 5 radical 3 squared plus 5 squared. The question is, does it equal 10 squared? Let's do a little bit of math. Let's check this out. 5 radical 3 squared, so we have 5 squared, that's 25. Radical 3 times radical 3 gives us 3, so we have 25 times 3 plus 5 squared is 25. Our question is, does that equal 100? Well, let's clean this up a little bit. On the left hand side, we have 25 times 3, that's 75. 75 plus 25, does that equal 100? Well, maybe it does. Well, 100 actually does, right? All right, there it is. And it looks like it works. A squared plus b squared says that this is in fact a right triangle, and one of those special ones, that 30, 60, 90, right? That's given the short leg. Okay, that's if we start off here. This is where we started. I'll put a little star there just so you can say that's where we started. Here. There's our legend. Start here. That's what it means. That's where we started the problem. Let's try this other one though. Let's say we had the length of the longer leg. Let's go ahead and throw in a number in there. And let's just use this random, let's call this 7 radical 3. Okay? So this is the longer leg because it is opposite of the 60-degree angle, opposite of the longest, of the bigger one between the 30 and the 60. Okay? Now, to go back, what we have to do is we have to divide by radical 3. Now, this is according to our conjecture. If this is, in fact, this is a 30, 60, 90 triangle, this is going to work. So divide this by radical 3, we end up with 7. Right? 7 radical 3 divided by radical 3. Let's put a little bit of math right up here, right? 7 radical 3 over radical 3. Anything divided by itself is 1. We end up with 7. Good. So we have the short leg. And remember, we need the short leg to get every other one. So now we have the short leg. Let's go ahead and find the length of the hypotenuse. To find the length of the hypotenuse, our conjecture says take the short leg and multiply it times 2. In this case, that would be 14. Let's see if this works. Let's throw this into the Pythagorean theorem. A squared plus b squared equals c squared. And we have 7 radical 3 squared plus 7 squared. Does that equal, right? Big question mark. Does that equal 14 squared? Well, maybe. Let's take another look. What we have is, let's see, square each of these individually. So we have 49. 7 squared is 49 times radical 3 squared. That's 3 plus 7 squared is 49. And the question is, the burning question is, does that equal 196? Well, that all depends on what 49 times 3 is, right? So 49 times 3, we got 147 plus 49. Well, what does that equal? Ah, you guessed it, 196. It actually works. 196 equals 196. So there you go. That's what it equals. Okay? So using the Pythagorean theorem, it actually works. Now, not all the problems are going to be that easy, right? Let's do another example with where the length, we'll start off with the length of the long leg, and it's not going to have a radical 3 now. It's going to have something else. So we are going to have to do a little bit of math to see how this works, and hopefully we get that the conjecture works. Okay, so let's call this one here. Let's say the long leg was 4. Let's throw in the radical 6. Okay, so we have 4 radical 6. To get the length of the short leg, what we have to do is we have to divide by radical 3, just like we did in the previous one. How does that work? Well, let's take a look. So we have 4 radical 6 over radical 3. We can actually break down the radical 6 as, well, we know that 2 times 3 is 6. So let's do that. 4 times radical 2 times radical 3 over radical 3. Look at that. Radical 3's go away, so that means that the short leg is 4 radical 2. Okay. Now from there, what we can do is they can actually find the length of the hypotenuse, right? Length of the hypotenuse, all we have to do is take that short leg as multiplied times 2, giving us an 8 radical 2. Those numbers are a little weird, but let's go ahead and check our work anyways, just to make sure that this conjecture is in fact true. So we have 4 radical 6, we'll use that as a squared, plus 4 radical 2, and we'll use that as b squared, and then the hypotenuse we have 8 radical 2 squared. Now let's go ahead and see if that works. So we have 4 squared, that'd be 16 times, well, this is a radical 6 times 6 plus, let's see, 4 squared is 16 times 2, and then here we have 8 squared, is that 64, and this is times 2. Throwing this into the calculator, we actually end up with 128 is equal to 128. So it does work, right? So that's good. Good stuff, you guys. So in summary, let's go ahead and do a quick little summary. What we have is the hypotenuse. We said the hypotenuse is equal to the short leg times 2. Short leg times 2. We also, let's talk about the long leg. We talked about that longer leg. That's going to equal the short leg. And we talked about how that was equal to the short leg times radical 3. And then the short leg is just itself, right? It plays itself in this here movie. So this is the short leg. And that's one of the ways that you can use you can use these equations and manipulate them to solve for the missing length.